Have you ever actually stopped to think about how the simple, seemingly unthinking sensors scattered all around us, like in our homes, our offices, our factories, somehow magically transform into intelligent, automated actions? Well, in this explainer, we're going to explore how that invisible magic actually happens behind the scenes. We're diving into the world of IoT data analytics, which is just this fascinating process that takes raw, incredibly messy data from the physical world and turns it into smart automation. But hey, before we get into the how, we've got to talk about the why. 60,000. That's a massive number, right? Well, that is exactly how many times faster our human brains process visual patterns compared to just reading plain text. And that staggering statistic is exactly why we desperately need robust data analytics. The Internet of Things produces mountains, frankly, deep, chaotic oceans of raw data every single second. Without a structured way to translate all of that noisy text and numerical data into visual, understandable insights, we'd be completely blind in a sea of information. So here's our roadmap for this explainer. We'll start with the data analytics journey, climb the 4 stages of analytics, explore some advanced analytical concepts, check out the power of visualization, and finally walk through the full life cycle. Let's get right to it. Section 1. The data analytics journey, making sense of the noise. Moving right along to Section 2, the 4 stages of analytics, climbing the maturity mountain. Okay, let's dive into this. In the world of the Internet of Things, information overload is basically the default state. You have thousands of sensors reporting their status every single millisecond. To cut through that noise and actually find the signal, we need a structured life cycle. And that involves climbing what we can think of as a maturity mountain. Because as data matures, it continuously escalates in complexity and, more importantly, value. At the very base camp of our mountain, we have descriptive analytics. The core question here is super simple. What happened? This just describes past or current events. For example, if you're managing a facility, descriptive analytics simply calculates the average temperature in a building today. It gives you the baseline facts, sure, but it doesn't tell you a thing about the why. From there, we take a bit of a cognitive leap into diagnostic analytics. Now, the question becomes, why did it happen? Instead of just looking at the surface, we're actually investigating the underlying causes of a specific event or pattern. Going back to that facility example, diagnostic analytics is what allows you to pinpoint the exact reason a specific sensor malfunctioned during a peak load. It's really the investigative detective work of the data world. Now we're elevating the stakes. We move into predictive analytics. The question changes entirely to what will happen. We are no longer just looking backward, we're using historical patterns to forecast future states. Imagine forecasting your energy usage so accurately that you can schedule your heavy machine maintenance precisely when grid prices dip. That is the kind of predictive power we are aiming for here. And finally, we reach the absolute peak of the mountain, prescriptive analytics. What action to take? This is the sweet spot where the system finally acts on its own, providing automated recommendations or even direct triggers. A perfect example is a smart building automatically adjusting its HVAC set points based on the occupancy predictions we just made in the previous stage. The system isn't just telling us what might happen, it's actively managing the environment to optimize it. Which brings us to Section 3, Advanced Analytical Concepts, the tools of the trade. Now, you might be wondering what actually powers those highly complex predictive models behind the scenes. Well, 2 fundamental concepts here are feature engineering and sliding windows. Feature engineering is really all about selection. It turns out you don't actually need all of the data, just the right data to create incredibly precise models. Sliding windows, on the other hand, are how engineers manipulate time. It's kind of like giving our system a rolling short-term memory, detecting trends over specific moving time periods, instead of getting totally bogged down by years and years of history. And that naturally leads us right into anomaly detection. You can instantly spot an anomaly. It just jumps out at you as a sudden, crazy spike in a vibration signal, or maybe an unexpected drift in environmental values. Anomaly detection is the automatic flagging of these statistical outliers that deviate from the established norm. And catching these deviations instantly, it's absolutely crucial for spotting security breaches, detecting pipeline leaks, or sending hardware aging alerts long before disaster strikes. So, a prime real-world application of all these tools is predictive maintenance. By continuously monitoring stuff like vibration, heat, or noise signatures in industrial equipment, we can literally predict a hardware failure before it even occurs. Just think about the impact of that for a second. It drastically reduces unscheduled downtime and massively cuts operational costs, simply because you fix the machine right before it breaks, not after it halts your entire production line. But listen, timing is absolutely everything here. For live safety systems or immediate motion control on a factory floor, delayed historical reporting is basically useless. We need real-time stream processing with zero latency. We're talking about moving from visualizing the history to live dashboarding that instantly visualizes the now. All right, section 4, the power of visualization. Seeing is believing. Remember that 60,000 times faster stat from earlier? That is exactly why strict design principles are absolutely mandatory when we're trying to quickly convey all this complex math. We establish a visual hierarchy, meaning we place the most critical info at the top left, because that's where our eyes naturally go. We use specific visual types, charts for trends, and heat maps for spatial sensor data across a floor plan. Throw in some highlighted alerts using colors for thresholds, and most importantly, reduce clutter to minimize non-essential information. Doing all this allows even non-technical stakeholders to grasp the exact situation instantly. And to actually build these clean, powerful visual experiences, the industry relies on a few absolute powerhouses. We're talking Grafana for professional analytical dashboards and Power BI for enterprise-wide intelligence. Need rapid prototyping? Node-RED is going to be your best friend. When you're dealing with specialized real-time storage for time series data, InfluxDB is the go-to. And for mobile-first dashboards, developers often rely on Blink. Basically, there is a perfect tool out there for every level of scale. And that brings us to our final stop, section 5, the full life cycle, tying it all together. So we've seen the stages, we've touched on the advanced math, and we've looked at the visual platforms. Really, the whole shebang boils down to this ultimate 5-step life cycle. Step 1, collect. We gather the raw sensor readings. Step 2, clean. We pre-process and filter that raw data just to remove the noise. Step 3, analyze. We apply our models to find statistical trends and run predictions. Step 4, visualize. We turn those heavy analytics into super clear dashboards and alerts. And finally, step 5, action. The loop closes as the system makes decisions and triggers actuators to physically change the real world. So we've gone from messy, raw data all the way to a fully automated, intelligent loop. But honestly, this leaves us with a pretty fascinating, almost philosophical question to ponder. As our algorithms climb that maturity mountain all the way up to prescriptive analytics, when everything from your office HVAC system to massive industrial factory floors can analyze, visualize, and literally prescribe their own future actions, what decisions will actually be left for us humans to make? Thank you so much for joining me on this explainer. Keep questioning the data around you.